Okay. All right, you guys, I'm going to start. I'm going to put in the video on here for those people that are absent. So there will be a video if you decide to fall asleep or just read a newspaper during class instead of watch my lesson.
It's
not on the deal list. So today what we're going to talk about is what the derivative, the power rule. Okay, and some of you I know already kind of know what this power rule is, but it's going to make your lives a lot easier. It's going to be sort of a shortcut way instead of having to do what you did on the quiz yesterday, which was do that whole limit thing a million times. We're now going to have a much shorter way to find derivative. But before we jump into that, and I kind of have to get through a lot, and I know it's a short period, so I'm going to skip the derivation of this here and just jump right to the constant rule, which you guys should be able to kind of figure out. Remember, derivative just means slope. So if we think of a constant function, what do I mean by a constant function? I mean something like y equals 5. So if I look at the graph of y equals 5, that's a constant function. What is the slope of this line?
0.
The slope is 0, right? And so therefore the derivative of any constant function is always going to be 0. Okay, so any constant function, your derivative is always 0. So they just wrote it in sort of derivative language here. dc dx, where c is a constant or a real number, that's just what a constant is, then the derivative is always equal to 0. And so using the constant rule, if y equals 7, what's the derivative of y? 0. And if f of x equals -3, what's the derivative of f? 0. And if y equals k times pi squared, where k is a constant, what's y prime?
0.
Okay, you got it. So that is the constant rule, nice and easy. Derivative of a constant is just always 0. All right, let's keep going. Now what we're going to do is try and figure out this pattern that we can do. We're going to use the long way to see if we can catch on to a pattern, which I already wrote on the board, so ignore that. Erase, don't look at the board. Close your eyes.
I don't understand.
Okay, you didn't see that. Okay, so let's do this first one. If f of x equals x to the first, let's use the definition of derivative to figure out our derivative here. All right, so we'll take the limit as delta x approaches 0. F of x plus delta x is just going to be x plus delta x. Minus f of x, that's just x. This is a nice easy one. Delta x over delta x is just 1. And so the limit as delta x approaches 0 of 1 is just 1. And so f prime is just 1. All right, let's try it for x squared. So go ahead, you guys can work this out. You did this a whole bunch yesterday. You might have used the other formula, but either one works. So x plus delta x quantity squared minus x squared over delta x. Go ahead and work that out. See what you get. Answers? 2x. You should have gotten 2x, right? So you'd have x squared plus 2x delta x plus delta x squared minus x squared. Right? Cancel, 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 cancel. 2x plus delta x. But again, it's the limit as delta x approaches 0. So I get 2x plus 0. Answer 2x. All right, so when f was x to the first, our derivative was 1. When f was x squared, our derivative was 2x. Let's do one more, see if we can figure out this pattern, okay? I'm not going to do all of them. I think that's a little overkill. But how about x to the third? Well, let's work this out. So we'll have x plus delta x to the third minus x to the third over delta x. So do you guys want to do difference of cubes or you want to use Pascal?
Pascal.
All right, we'll do Pascal. 1, 3, 3, 1. X cubed, x squared, delta x delta x squared, delta x cubed. Don't forget there's still this minus x cubed there, plus, plus, plus. All right, cancel, cancel. And the delta x's, gone, gone. There's 2 of them left there. So I have 3x squared plus 3x delta x plus delta x squared. Again, limit as delta x approaches 0. So I just get 3x squared. All right, so now let's see if we can figure out the pattern, right? Oh, I'm on a video. They can't see the board. I'll write it on here. So what have we done so far? We did that if f of x was x, f prime was 1, right? That was the first one we did. Then we did, what if f of x equals x squared? F prime was 2x. And now we just did x cubed. And what did we get?
3x squared.
3x squared. All right, so do we see any connections, any patterns, any, like, how do we get from here to here? What are you guys seeing here? Some of you guys catch on? Yeah, Nick, I know you're dying to say it. Go ahead.
Okay, so for the x cubed,
Yes.
we're going to drop the 3 from the cubed in front of the x and multiply it by the x, and then you're going to subtract that 3 by 1. So you get the 2.
Does that work for this one too?
It does.
So if I take the 2, bring it in front, and then subtract that 2 by 1, I get 1. And did it work for this one?
Most definitely.
If the exponent was 1, move it in front, I get a 1, and then subtract 1 minus 1 would just be 0. And so, ta-da! That's your power rule. Best thing ever. Okay, let's try it. What if it was x to the 4th? Everybody try it. 4x to the 3rd. Isn't that amazing? What if it was x to the 57th?
57x to the 56.
Right? Okay. So you guys get the idea. This is power rule, okay? Obviously, and the question everyone asks is, why did you not show us that a week ago? Right? Why have we been having to do this out the long way for the past week? Why was that quiz so much killer yesterday? If we had a power rule in that quiz, we could have zipped through that whole first page, right? There are still going to be questions where you have to do this whole long method. On the final exam, there's still going to be questions that say use limits, use the definition of derivative to work it out like this, okay? You do need to know where it comes from, right? You need to know the backup. This is a limit thing. It's not just move it in front. You know, anyone, I mean, a monkey could do power rule, right? It's not that high level. This is really where the hard work comes in, is the derivation of it and what's behind it, okay? So you do need to still know how to do that. That's not to say that, you know, on some of these questions, you can't just fly through them now. Multiple choice ones, other ones, checking your work, you can definitely now use the power rule, okay? So for x to the 4th, again, I'm not going to make you show this all out. You just use your power rule, and you'll just have 4x cubed. How about x to the 1/2? How's that one going to look? Yeah, so we have x to the 1/2, which would move in front. So I'd have 1/2, and then I'd subtract 1. So that would be negative 1/2. And then we usually want to leave our answers with positive exponents. And then we also, instead of fractions, would prefer those to be written with radicals. So what would this one look like?
1 over 2 root x.
That's what I would do. Yeah, go ahead. Yeah, so then in terms of rationalizing, you don't have to rationalize pretty much ever again in your lives. So you're good. I mean, the only time you rationalize stuff is like to rationalize a numerator, to rationalize a denominator when you're trying to simplify something. But in terms of leaving your final answers with radicals in the bottom, totally fine at this point, okay? Especially if it's got an x there. So that would be okay. All right, so then how about x to the negative 1? Negative 1 comes in front. So it'd just be negative 1x to the negative 2, because minus 1 would give me negative 2. And then again, I want to bring that to the bottom to make it positive. So my f prime would just be negative 1 over x squared. Look good? And that's power rule, okay? So we're just going to practice a lot of this now. So go ahead and turn the page. It shows you the power rule written out as a theorem, sort of with variables here. So you can see if n is a rational number, then f of x equals x to the n is differentiable, and the derivative is equal to, so all they did is took that n, moved it in front, so that's where you get the n here, times x to the n minus 1. Now notice in order to do this, that x term needs to be on the top, so you need to have an x in the numerator. If the original problem has the x on the bottom, first step you need to move that x up to the top, and then you can do your power rule, okay? Example 2, go ahead and practice, you guys. Do the power rule for those three. See what you get, and then look up and check your answers. All right, first one is obviously 5x to the 4th. The second one, just make sure you rewrite it with positive exponents and square root. So I believe you should have 1 over 3 cube root of x squared. Yeah, Monica, go ahead.
When you do the exponent 2, do you have to put parentheses around everything?
So you don't. No, you could just put the 2. So it's kind of the same thing. Like you could either say cube root of x whole thing squared. That would be fine. Or I'm just kind of lazy and I don't want to write those parentheses, so I just scoot the squared underneath it, and that's the same exact thing. So it's either the square under it or the square on the outside. It doesn't matter. So either way would be fine. Okay. And then this last one, negative 2 over x cubed. We good? Questions? So far, so good? All right, so now find the slope of a graph. Well, we can do that because the slope is just the derivative, right? And so all we're going to do is use our power rule now. So if f of x equals x to the 4th, what is f prime? What's the derivative? 4x cubed. And now that I have my derivative, I'm just going to plug in these 3 points, and that's going to find the slope at those 3 points. Much easier than everything we've been doing for the past few months to try and find the slope, right? Okay, so, oh, my babysitter's calling. That's not good. She's probably at my house and my kids aren't there yet. Pausing, sorry. Pause for a sec.